Welcome to my class introduction. Class standard 12, subject higher mathematics, first paper, chapter name permutations and combinations, exercise 4b, lecture 4. Today is the last lecture on this exercise. Okay, today's lesson: to solve the problems related to the combinations. Problem: if 2NCR this equal to 2NCR plus 2, find the value of R. Solution: given that 2NCR this equal to 2NCR plus 2, as 2NCR and 2NR plus 2 are equal, so we can write R plus R plus 2 this equal to 2N. Okay, this part and this part same. Formula: if NCX this equal to NCY this equal to, can write X plus Y this equal to N. That's mean this plus this equal to this or this. That's mean this and this are same. For clear concept, we know 4C3 this equal to 4 and 4C1 this also equal to 4. Okay, as 4C3 this equal to 4 and 4C1 this equal to 4, therefore we can write 4C3 this equal to 4C1. Clear? Now follow here properly. Here 3, here 1. 3 plus 1 mean 4. This equal to this or this. Clear? Okay, now calculate this part. Here R plus R mean 2R, and this to convert into right side we will get 2N minus 2. That's mean this. Now dividing on both sides by 2 we get R is equal to N minus 1. This is the answer. Okay, and here this part, that's mean yellow part, this is a side note. Okay, assessment problem: if NCR is to NCR plus 1 is to NCR plus 2 this equal to 1 is to 2 is to 3, find the value of N and R. Another problem: if NPR this equal to 240 and NCR this equal to 120, find the value of N and R. Problem: find the number of combinations of the letters of the word thesis taken 4 letters at a time. Solution: here the word thesis consists of 6 letters, of which 2 S. Yes, here S repeat 2 times. Okay, and others are different. That's mean T, H, E and I are different. But when we consider 2S as a single S, then total 5 different letters will be. Clear? So out of 6 letters, 4 can be taken under the following OS. All are different. When all are different, if 2S considered as 1, okay, that's mean 2S considered as 1, that's mean 6 minus 2 plus 1. Okay, so total 5 different letters. From here we have to take 4 and can be selected in 5C4, that is equal to 5 factorial divided by 4 factorial into 5 minus 4 factorial. We know the relation. This equal to 5 into 4 factorial divided by 4 factorial into 1 factorial. This equal to 5 by 1. This equal to 5 OS. For clear concept, the combinations are THES all are different. THEI, THIS, TIES, ISES. That's in total 5. But when we take 2S, then other 2 will be different. But other 2 will be filled up from 4 different letters, as we have to take 2S fixed. So other 2 places will be filled up from 4 different letters in 4C2 OS. Now follow. 2S fixed and 2 letters are different. So out of remaining 4 letters, other 2 can be selected in 4C2. Other 2 mean as 2S is fixed, so we have to take another 2, but from 4 different letters, because other than 2S, 4 different letters mean T, H, E and I, and the way total 6. After calculate, we'll get this. For clear concept, follow here. 2S fixed, another 2 places, that's mean this place and this place, that's mean 3rd and 4th places will be filled from 4 different letters, but place will be 2. We have taken here TH, here TI, here TE, here HI, here ACA, here I, and total 6 ways. Clear? Therefore, the required number of combinations equal to 5 plus 6. This is equal to 11. This is the required answer. Clear everyone? Okay. Now assessment. In how many ways can any 4 letters be selected from the word degree? Like as before math. So I think that everybody can solve easily. Problem: in how many ways a cricket team consisting of 11 players can be formed from 2 groups containing 6 and 8 players, so as to include at least 4 players from the group of 6. Here 2 groups, one is 6 members and another one is 8 members, that's mean 8 players. But you have to make a team of players 11, but there is a condition. From the first team, that's mean a team whose member 6, you have to take at least 4. At least 4 mean you can take 4 or 5 or 6. Clear? You can take 4 or you can take 5 or you can take 6. At least. That's mean 4, 5 or 6. At most, when here is at most 4. At most 4 mean we can take 1, 2, 3 and 4. But at least 4 mean you have to take 4, 5, 6. Clear? Now follow the solution. The team consisting of 11 players can be formed under the following ways. Group of 6 players, group of 8 players. The number of ways to form a team. Follow here. At first, I have taken 6 players because we can take 4, 5 and 6, as the question was at least 4 players from the groups of 6 players. So at first I have taken here 6. Total number will be 11. So from this group we have to take 5. As a result, 6 plus 5 will be 11. Okay, but the process will be here. Total number of players 6. We have taken 6. So the combinations or number of team or collection will be 6C6, and from here 8C5. 6C6 this equal to 1 and 8C5 this equal to 56, this equal to 56. Now we have taken here 5. So from 6 we have to take 5. So here will be 6 because 5 and 6 make 11. So these are correct. And the process for finding 5 players from 6 players and 6 players from 8 players, this equal to 6C5 into 8C6. 65 this equal to 6 and 8C6 this equal to 28. This equal to 168. You can use calculator or you can solve. Here 4. Here will be 7 because 4 plus 7 is equal to 11. And the way for selection 4 from 6 players, this equal to 6C4, and 7 players from 8 players will be 8C7, and total number of team will be 15 into 8, that means 6C4 equal to 15 and 8C7 is equal to 8, this equal to 120. Therefore, the required number of ways to form a team is equal to 56 plus 168 plus 120, this equal to 344. This is the required answer. Clear everyone? Another problem, the straight lines of length 1, 2, 3, 4, 5, 6, 7 centimeter respectively are given. Show that the number of ways in which 4 can be chosen to form a quadrilateral is 32. Solution. The number of ways can be chosen. 4 lines from 7 lines is 7C. 4 this equal to 35. But we know sum of any 3 sides of a quadrilateral is greater than the other side. As a result, the set of 4 lines, that's 1, 2, 3, 6 from here 1, 2, 3, 7 and 1, 2, 4, 7 cannot be on a quadrilateral because 1 plus 2 plus 1 plus 2 plus 3 this equal to 6, not greater than 6, but that will be greater than 6. 1, 2, 3, that's 1 plus 2 plus 3 this equal to 6, which is less than 7. So this is not possible to form a quadrilateral. And here 1, 2, 4. 1 to 4 means 7. 7 and 7 are equal, not 7 greater than 7. Okay. Therefore, the required number of quadrilateral 35 minus 3. This equal to 32. This is the required result. Is this part. Hence proved or showed. Another problem. This is a mixed of permutations and combinations. How many permutations and combinations can be made from the letters of the word professor, taken 4 at a time? Solution. Here the word professor consists of 9 letters, of which 2 are 2 O's and 2 S. That's mean here R repeat 2 times this and this, O repeat 2 times this and this, and S repeat 2 times, that's mean SS. Now out of 9 letters, 4 can be selected under the following possibilities. A number, all are different. When all are different, if we consider 2R, 2O and 2S as 1, and B number, 2 letters are alike and 2 letters are different. C number, 2 letters are alike of one kind and 2 letters are alike of another kind. For the selection of A, that's mean all are different. All are different means out of 6 different letters. Out of 6 means 9 minus 3, because here 2 are considered as 1 or 2 is considered as 2O considered as 1O and 2 is considered as 1S. So total will be 6 different letters, and 4 letters can be selected in 6C4. This equal to 15 OS. Okay, and these selected 4 letters are arranged among themselves in 4 factorials. 4 factorials mean 24 OS, and we know a relation. We know a relation mean NPR, this equal to NCR into R factorial. So here NCR mean 6C4, this equal to 15, but NPR this equal to, we know, NCR into R factorial. That's mean 6C4 into 4 factorial. This is a permutation, but combination 6C4. Now follow the next line. Therefore the number of combinations equal to 15. Okay, no problem, but permutation will be NCR mean 15 into R factorial. R factorial mean 4 factorial. After calculating, we'll get 15 into 24, this equal to 360. So this is combination and this is permutations. B number, for the selection of B, that's mean out of 3 pairs of 3 kinds, 1 pair, that's mean 2 letters, can be selected in 3C1. This equal to 15 OS, because there is 2 and 2S. As we have to take in 1 pair same kind, so 1 pair can be selected in 3C1. This equal to 15 OS. And the rest of 6 minus 1, that is 5 letters, are selected in 5C2S. This selected 4 letters in which 2 letters are arranged among themselves in 4 factorial divided by 2 factorial. This equal to 12 OS. Therefore the required number of combinations, 3C1 into 5C2, this equal to 3 into 10, this equal to 30. Here 3C1, this equal to 3, not 15. So here will be 3, and 5C2, this equal to 10, and 3 into 10, this equal to 30. And permutations will be combination into R factorial. R mean 4, so 4 factorial divided by 2 factorial, this equal to 2s, because two letters are alike of same kind. So 30 into 12 is equal to 360. For the selection of C, that's mean out of 3 pairs of 3 kinds, 2 pairs, that's mean 4 letters can be selected in 3C2, this equal to 3OS. And the combinations will be RROO or RRSS or OOSS. You can follow this. 3OS mean RROO or RRSS or OOSS. Clear? This selected 4 letters in which 2 letters are one kind and 2 letters are another kind are arranged among themselves in 4 factorial divided by 2 factorial into 2 factorial. This equal to 4 into 3 into 2. 2 factorial means 2 and 2 factorial fixed because we have to cut this and this. As a result, here will be 6 ways. Therefore, the number of combinations this equal to 3 and permutations this equal to 3 into 6 this equal to 18. Therefore, the required number of combinations this equal to 15 plus 30 plus 3 this equal to 48 and permutations this equal to 360 plus 360 plus 18 this equal to 738. This is a required answer. That's mean combination 48 and permutation 378. Clear everyone? I tried to solve different kinds of math on this exercise. Now I think that everybody will can solve the other math on exercise 5b. So everybody will try to finish the exercise 5b and submit the copy in the group, and date of submission will be 30/8/2020 at 9 p.m. Okay, today up to this. Thank you to all everybody.